Okay, this is chapter 9.2, special right triangles. Essential question is, what is the relationship among the side lengths of a 45-45-90 triangle and a 30-60-90 triangle? What you will learn in this chapter section is finding side lengths in special right triangles and solving real life problems involving these special right triangles. So let's take a look. Okay, before we get started though, there's our theorem, our fourth theorem of the chapter section, or chapter 4, or chapter 9, theorem 4. 45-degree, 45-degree, 90-degree triangle theorem. In a 45-degree, 45-degree, 90-degree triangle, like shown here, the hypotenuse is the square root of 2 times as long as each leg. So in this diagram, I have a square, and I'm going to show you why I have this square here. So let's make this larger so you can see it better, especially if you're on a phone. So here's a square. Well, what do we know about a square? Okay, well, its sides are all equal. So let's call them x. So there are 4 sides, same length every side. And we know a square has 4 90-degree angles. Okay, so there's my 90-degree angle markers. Now what I'm going to do is I'm going to choose a dashed line. Let's make it purple. And I'm going to cut it diagonally like so. Okay, so if I cut that in half like that, this is an angle bisector. So now this is 45 degrees because it was 90 and half of 90 is 45. So 45 and 45, that's still a sum of 90, and same with down here. So we have 45 degrees here and we have 45 degrees here. Okay, so now let's ignore this side. Okay, ignore this side. And now we have this side here, or this triangle here. Let me get rid of this here because I'm going to write here. So we're ignoring this top half and we're focusing on the bottom half here. So as you can see, I have side X, I have side X, 45 degrees, 45 degrees. So that's where this comes from, cutting a square in half. But how did we find this? Well, the Pythagorean theorem says a squared plus b squared equals c squared. I like putting the c squared on the left. I don't know what c squared is, so I'm going to just leave it c squared. But a is x, so I'm going to substitute in x. B is also x, so I'm going to substitute in x. Simplify. C squared equals x squared plus x squared, which is 2x squared. How do I get c by itself? Take the square root of both sides. When I take the square root of c squared, I get c. When I take the square root of 2, I get an irrational number, so I'm just going to leave it square root 2. If I take the square root of x squared, so in other words, what I can do is break this down like so, and there's a 2 here, and there's an x squared here. So the square root of 2 just stays the same, but the square root of x squared, the square root and the x's cancel, or the square and the square root cancels, I mean, leaving me with x. So I get c equals x square root 2, and there it is. So that's where this theorem comes from. Hopefully that makes a ton of sense to you. There is a proof, but I'm just going to show it to you this way. And let's move on. Okay, so now we're going to apply that theorem, and we're going to find values of special right triangles using that theorem. So find the value of x, write your answer in simplest form. So notice this is a 45-degree angle, so therefore this has to be 45 degrees. So it's a 45, 45, 90. The legs are equal, 8, 8. Now let's go back. So if x is 8, our hypotenuse is x times the square root of 2. So what this means is the hypotenuse equals the leg times the square root of 2, if you will. In other words, all you have to do is say the hypotenuse in this situation equals 8 square root 2. Okay, so let me go back here. In a 45, 45, 90, the hypotenuse is square root times as long as each leg. So you take the leg times the root 2. So here's a leg. Here's the leg times square root of 2. Here's a leg. Here's the leg times the square root of 2. So the hypotenuse is 8 square root 2. Okay, so in this situation, remember it's x square root 2. Well, we're working backwards now. What is x? It's right there, it's 5. So in this case, x just simply equals 5. And that's the easiest way I can explain that. The way the book shows it is it says the hypotenuse equals leg times the square root of 2. And we know that the leg is 5, or the hypotenuse is 5 square root 2. So we write 5 square root 2 equals the leg square root 2. So therefore the leg equals the square root of 2. I'm sorry, equals 5. So let me fix that. Okay, so hypotenuse equals the leg times the square root of 2. The hypotenuse is 5 square root 2, which is the leg square root 2. And I want to find the leg. I divide both sides by the square root of 2, divide by the square root of 2. This cancels. I'm left with a leg equal to, these cancel, 5. Okay. This is much easier. If you just think x square root 2, the x is 5. All right, so now you should be able to do problem numbers 34, 3 and 4, 3 and 4. Do problem 3 and 4 in your exercises. Actually, 3, 4, 5, and 6. Okay, here's the 5th theorem in chapter 9, and it is the 30-degree, 60-degree, 90-degree special right triangle theorem. In a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is square root 3 times as long as the shorter leg. So there it is. Where does that come from? Well, again, like I did with the square, I'm going to take this equilateral triangle. Let me make it larger so you can see it. There's an equilateral triangle. I'm going to name the sides 2x. So since they're equilateral, they're all 2x. And what do we know about equilateral triangles? We know they're equiangular. And 60 degrees times 3 is 180. So they're all 60 degrees, 60, 60, 60. Okay. I'm going to then go and I'm going to get a purple line segment, and I'm going to cut this. Whoops. Ooh, that wasn't a straight line. Yikes. Let me try that again. Let's do here, here, and purple, and set that there, and drag that down like so. That is an altitude. That's called an altitude. I formed a 90-degree angle with the base. It cut this in half. So now this angle is no longer 60 degrees. It is 2 30-degree angles. So we have a 30, 60, 90 triangle. And let me put this here. This is also 90 degrees. And now I'm going to scribble out this side. I don't want to look at that. Oh, and by the way, if this whole thing is 2x, then this is x and this is x. So I just split that into 2 equal pieces because x plus x is 2x. So ignoring this side, this is this triangle right here. So we know x, we know 2x. That's, whoops, I forgot to go back to my pen. This is x, this is 2x. Well, to find this side, that's my other leg. Hypotenuse is 2x, so I'd say c squared equals a squared plus b squared. 2x is my c, square the quantity. A is x plus, I don't know, b. Distribute this, and I get 4x squared equals x squared plus b squared. Subtract x squared. We're trying to solve for b, aren't we? So I get 3x squared equals b squared. I'm going to take the square root of both sides. So I get b equals, I can't take the square root of 3, so I'll just leave it. And the square root of x squared is x. And therefore we get x square root 3 here. Okay? And so that's how this came about. So there is a proof on page 476. I'm not going to do it. I'm just going to show you with this. And let's see how this gets used. Okay, so here's example 2. Find the side lengths in a 30, 60, 90 triangle. Find the values of x and y. Write your answer in simplest form. So I always like to copy the diagram and then set it up. So if this is 30 degrees and this is 60 degrees and this is my 90-degree triangle, The side opposite 30 is x, the hypotenuse is 2x, and the side opposite 60 is x square root 3. And that came from the height of cutting the equilateral triangle in half. So now all I need to do is take what I know and set it equal to the formula from here. So the side opposite 60 is x root 3. X root 3 is 9. So that's what we do. We say x square root 3 equals 9. Divide both sides by the square root of 3. And these cancel. And I get x equals, well, I don't want a radical in the denominator. So I'm going to multiply the top and bottom by the square root of 3. It's called rationalizing the denominator. And root 3 divided by root 3 is simply 1, so I'm not changing a value. And 9 times the square root of 3 is just simply 9 square root 3 over square root of 3 times the square root of 3 is the square root of 9, which is 3. And then this 9 divided by 3 reduces to 3 square root 3. Okay, so there's x. Now I'm going to find y. Well, y is 2x, and here's x. So y equals 2x. Here is x, so you just substitute it in here. Y equals 2 times 3 square root. Let me do that in red, because that's what I'm substituting in. 2 times x. Well, what is x? 3 square root 3. Okay, and then when I multiply that, I get y equals 2 times 3 is 6 square root 3. Okay, and there you have it. X is 3 root 3, y is 6 root 3. So now you should be able to do problem number 7, 8, 9, and 10 in your exercises. Okay, so here's example 3, modeling with mathematics. The road sign is shaped like an equilateral triangle. So there's the key to this problem. Equilateral meaning all sides are equal. So in other words, this is 36, this is 36, and this is 36. So in this diagram, what has happened here is we created a triangle and dropped a hypotenuse, or I mean an altitude, dropped an altitude, which is going not to be the hypotenuse, but it's going to be the longer leg. So splitting this 36 into 18 inches and 18 inches, where this side's 36 still, and so is this. So now we have a right triangle, and this is 30 degrees, and this is 30 degrees, and these are 60, 60, so it's a 30, 60, 90 triangle. So it says, estimate the area of the sign by finding the area of the equilateral triangle. So in other words, you want to find the area of one side. So area equals 1/2 base times height. So the area equals 1/2. My base is 18. Okay. But I don't know my height. Okay. But I'm not going to do the Pythagorean theorem. I'm going to do what we're doing in this chapter section. And since I want to know what the sides are, again, go with your trusty drawing of a equilateral or a 30, 60, 90 triangle. So I'm now just going to manipulate this and rotate it so it looks like one of these. Okay, so let's see, let's move it right on top of it so we can get it about the same. Okay. Right about there is close enough. And let's make it thinner. Okay, so here is our triangle. We know this is 18. This is going to be 36. So this is x, this is 2x, this is x square root 3. That's what we're trying to figure out here. And since this is x square root 3 and x is 18, then the height is 18 square root 3. 18 square root 3 because it's x is 18. So it's going to be 18 root 3. Okay. So I'm going to get rid of a half and this 18 and make that 9 just to make it easier. And it doesn't really matter because we're using a calculator anyway. So clear, and I'm going to say 9 times 18 square root 3. Actually, first of all, I just want to show it as 9 times 18. Okay, which is 162 square root 3. And then we're going to do that approximation. So A is approximately 162 square root of 3 equals approximately 280. Is that right? Did I do that right? 9 times 18 square root 3, enter 280. Okay, the book is showing 561. Oh, yeah, okay. So since one side is 280 and a half approximately, 280.59, okay, that's one triangle. It said find the area of the equilateral triangle. So I get my calculator back. Let me just do this so we can see both. And 280.59, since these two triangles are equivalent, that would be the area of the whole sine. Now I just multiply by 2, and I get the area equals 2 times 280.59, which is approximately 561.2 inches squared. Okay, so there is an approximation out to the nearest tenth. It didn't say what to round to, but I just did it to the 10th. So that's how you use special right triangles to answer real life type questions. Now you should be able to do problem numbers 15 and 16 in your exercises. Okay, example 4. Again, let me just go like this and let me copy this. So I'm going to go like this, Control C, go like this, Control V. Here it is, rotate it. Okay, and flip it horizontally. There. Okay, so here is my triangle. Okay, roughly the same. So I'm just going to move this over here and I'm going to use it as my template. I think this is the best way to do it. So here's X. The hypotenuse is 2X and the height is X square root 3. So we were given this as 80 feet, the ramp. So here is the ramp here, 80 feet before lifting it, and then it goes up like so. So the tipping platform is a ramp used to unload trucks. How high is the end of an 80-foot ramp when the tipping angle is 30 degrees and when it's 45 degrees? So let's first start one with 30 degrees. Okay. And so we're trying to find this value here when we know this is 80. Okay. So what's the question asking? How high is the end of the ramp? Oh, my fault. This isn't 80. This is the ramp 80 feet. When you tip it up, now this is the ramp. So this is your 80-foot distance. This we don't know. So 2x equals 80. Okay, not 80 here. So 2x equals 80. Since 2x equals 80, we divide by 2, we find x. So x equals 40. And foot, 40 feet. So x, the height of the ramp, is 40 feet. Okay, now it's saying, what about 45-degree angle? So let me do another triangle, like so. Here's a 45, 45, 90 triangle, a little bit thick. How about going totally thin? How's this? Okay, so this is a 45 degree, 45 degree. This here still 90. Here's my ramp right here. This is my ramp. And it is 80 feet. So this triangle is going to be x, x, and this equals x square root 2. Okay, so in order to find this, I'm going to use this equation right here. X 80 equals x square root 2. All we have to do is divide both sides by the square root of 2. and I get x equals, and I don't like a radical in the denominator, so I'm going to rationalize it. Root 2 times root 2 is 2, and it's going to be 80 square root 2, and then that simplifies to 40 square root 2. Okay, and if we want to know the height, then we would now say x is approximately, and get our calculators out, and do 40 square root, turn it on first, clear, 40 square root 2, enter. And it's approximately 56.6 feet off the ground when the truck is lifted to a 45-degree angle. Okay, so the answers to these problems were 40 feet when the angle was 30 degrees and 56.6 feet when the angle was 45 degrees. Okay, so now you should be able to do problem number 17 in your exercises. Okay, that brings us to the end of chapter 9.2. Here are the exercises I assigned, 26, 27 being review questions. Thanks for watching and have a great day.